An instance of the Splunk Enterprise running. Show you here that we have all the tokens configure and enable in order to use the system from our code. Basically, we also have to install several applications. One is the AI toolkit. As you can see here, we have it connected with our own LLMs. So I configure Gemini with the Gemini 3.5 Flash, and this is working fine. We have integrated the Splunk MCP server, and we have been successfully used it since from start. As you can see, there are a bunch of calls and success rates. It works pretty flawless. Our code generated the ZKSplunk app, which is installed via file. As you can see here, we created the SPL file that again, here we have the A toolkit. Let's question something. Is there any problem with our proof server? You can see Splunk sends all the relevant information to the LLM, and here we have no problem detected. Proof server is healthy, everything is fine, and it's giving us several information that is gathered from the Splunk server. Splunk, we are going to simulate an attack on the proof server, which is the one that we can control in the local environment. And then for you to see how all this works, I'm going to throw down the proof server, and we're going to see that service stops and generates a critical event. So I stop it. There we go. Proof server is critical. If we click on it, we can see that there is an event. The event is the vital check that is stating that it's critical. So the proof server is out, and well, we can also see application with a lot of information about the component that trigger identification, a link to check directly on the Splunk server what happened, and this is a notification that we can see we've been using a lot of components. When every single key component fails, it throws an email to the admin, and also we can check here in the summary all the information about the event. Splunk server, as you can see, we have it here, and then we can see the status of the network. We can see that the contract is deployed. There are one operator register, no change attestation, the reader's frequency. And then we can also see the relier. There are 19 previous incidents that we saw there, but no attestation submitted on chain because they were previous to our. Now we can see there is an event there, attestation submitted on chain. And we can see the event there and all the information on that event. Logged in, we can also see there the attestation transaction that we can copy, and we can also see it on the chain. There you go. That's the identifier. The ledger, as you can see there, is a critical incident that we reported to the chain, and then everything looks great on the network attestation. So we made Splunk integrated with the network, attesting critical events on chain. That's a unique characteristic of our repo, and it works like charm.